Software engineering. Introduction. Objectives: to define software engineering and to explain why it is important, to introduce the concept of a software product and the attributes of well-engineered software, to describe the basic activities of the software engineering process, and to illustrate a number of generic software process models. To explain why software process visibility is essential for process management, to explain why software engineers must consider their responsibilities to the engineering profession. Contents: software products, the software process, Boehm's spiral model, process visibility, professional responsibility. In all industrialized countries and increasingly in developing countries, computer systems are economically critical. More and more products incorporate computers in some forms. Educational, administrative, and healthcare systems are dependent on computer systems. The software in this system represents a large and increasing proportion of the total system costs. The effective functioning of modern economic and political systems therefore depends on our ability to produce software in a cost-effective way. Software engineering is concerned with the theories, methods, and tools which are needed to develop the software for these computers. In most cases, the software systems which must be developed are large and complex systems. They are also abstract in that they don't have any physical form. Software engineering is therefore different from other engineering disciplines. It is not constrained by materials, governed by physical laws, or by manufacturing process. Software engineers model parts of the real world in software. These models are large, abstract, and complex, so they must be made visible in documents such as system designs, user manuals, and so on. Producing these documents is as much part of the software engineering process as programming. As the real world, which is modeled, changes, so too must the software. Therefore, software engineering is also concerned with evolving these models to meet changing needs and requirements. The notion of software engineering was proposed in the late 19th century years at conference held to discuss what was then called the software crisis. This software crisis resulted indirectly from the introduction of third-generation computer hardware. These machines were orders of magnitude more powerful than second-generation machines. Their power made hitherto unrealizable applications a visible proportion. The implementation of these applications required large software systems to be built. Early experience in building large software systems showed that existing methods of software development were not good enough. Techniques applicable to small systems couldn't be scaled up. Major projects were sometimes years late. They cost much more than originally predicted, were unreliable, difficult to maintain, and software performed poor software performed poor and performed poorly. Software development was in crisis. Hardware costs were tumbling while software costs were rising rapidly. New techniques and methods were needed to control the complexity inherent in large software systems. After almost 30 years of development, we have made enormous progress in software engineering. Productivity improvements are hard to quantify, but there is no doubt that our ability to produce efficient and dependable software has markedly improved. We have a much better understanding of the activities involved in software development. We have developed methods of software specification, design and implementation. New notation and tools reduce the effort required to produce large and complex systems. Nevertheless, many large software projects are still late and over-budgeted. Software is delivered and installed which doesn't meet the real needs of the customers buying that software. New technologies resulting from the convergence of customers buying that software. New technology resulting from the convergence of computers and communication systems place new demand on software engineers. Software engineering has come far in its short time. It still has far to go. 1.1 Software products. The objective of software engineering is to produce software products. Software products are software systems delivered to a customer with the documentation which describes how to install and use the system. In some cases, software products will be part of systems products where hardware as well as software is delivered to a customer. Software products fall onto two broad classes. 1. Generic products. These are standalone systems which are produced by a development organization and sold on the open market to any customer who is able to buy them. Number 2. Bespoke customized products. These are systems which are commissioned by particular customer. The software is developed specially for that customer by some contractor. Until the 1980 years, the vast majority of software systems which were sold were bespoke, specially designed systems which ran on large computers. They were expensive because all the development costs had to be met by a single client. Since the development of personal computers, this situation has completely changed. The personal computer market is totally dominated by software products produced by companies such as Microsoft. This accounts for the vast majority of software sales. These are usually relatively cheap because their development cost is spread across hundreds or thousands of different customers. However, there is still a large market for specially designed system. Hardware control always requires some kind of special purpose system, as computers are embedded in more and more devices. There is an increasing demand for software controllers Consequently, most software development effort is still probably devoted to producing bespoke systems rather than shrink-wrapped software products. The problems of software development and the software engineering methods which may be used are the same for software products and bespoke systems. The most significant difference is that generic product specifications are produced internally by the marketing department of the product company. They reflect what they think will sell. They are usually flexible and non-prescriptive. By contrast, specifications for bespoke systems are often the basis for the contract between customer and contractor. They are usually defined in detail and changes have to be nationalized and carefully costed. 1.1